Yeah, good morning, everyone. My name is Lynn, Karoly, and I'm going to be chairing this first session, Valuing Mortality Risk Reductions. Jim will be leading us off with his presentation, and then we have discussion. Anna Alberini and Maureen. I'll be doing time from here, so watch for my cards. And then we're going to be saving plenty of time for discussion. So, Jim.
Thanks, and thank you to everybody for coming. What I want to do in this introductory session is spend a little time on the concept of valuing mortality risk, because there's a lot of confusion about this. I want to try and set that straight, talk a bit about terminology, and then I will go to our recommendations for how we recommend valuing mortality risk in low and middle income countries and benefit cost analysis. In brief, the recommendation will be, if you have good direct estimates for the country of concern, use them. That's unlikely to be the case, so most of the time the recommendation will be to start with estimates from a high-income country, specifically the US, extrapolate to the other countries, adjusting just for income. Even if you do have direct estimates, we'll suggest doing this extrapolation as a standardized sensitivity analysis to compare the results of the BCA in the one country with results for other countries. And to do this extrapolation, we suggest starting with two different values, a high value and a lower value, and then two different ways of adjusting for income. One assumes the value is proportional to the income, the other assumes the value is more than proportional to the income. And then we also suggest doing some sensitivity analysis for the age of the people affected, where that's relevant. Okay, so the money value of mortality risk reduction is defined as an individual concept, and it's the individual's rate of substitution between their own money, or realistically their household's money, and their own mortality risk in a defined period of time. Obviously, mortality risk over the next hour, month, year, decade, and century are very different things, so it matters which one you're talking about. Typically, we're thinking of near-term, relatively short period like the current year. Typically, we talk about the marginal rate of substitutions. That's the idealization for an infinitesimally small change in risk. How much money is that worth? Often in practice or in an analysis, you're talking about a finite change in risk, a small change, and so that's approximately the marginal rate of substitution times the size of the risk change. So the money value of anything in economics is the amount of money that has the same effect on well-being as the thing being valued, the change in mortality risk or some other good or service. So technically, that's either the compensating variation or the equivalent variation, depending on exactly what you're using. All right, terminology. So this, as I've emphasized, is a rate of substitution between money and mortality risk. It's a ratio. Anytime you have a ratio, the units are arbitrary. You have your choice of units. You can express it in different ways. So probably the most common term in the literature is the value per statistical life, which is the money value of a 1 unit change in probability, meaning from certain death to certain survival. But it's just a rate. It doesn't mean that's the value of saving your life for sure. The Commission on Investing in Health, which was conducted by Dean Jameson, Larry Summers, and Ken Arrow, and we'll hear from Dean and Larry Summers tomorrow, proposed a term, the value of a standardized mortality unit. Standardized mortality unit meaning a 1 in 10,000 change in risk. And so the value of a standardized mortality unit is just 1 over 10,000 times value per statistical life. Back in the very early days of this subject, a fellow named Ron Howard, a professor at Stanford, proposed the idea of a micromort, a 1 in a million change in mortality risk. And so the value of a micromort would be just 1 over 1 million times the value per statistical life. These are all exactly the same concept, it's just different units. And currently, the Environmental Protection Agency is working to recommend some new term, and we're waiting to see what they recommend rather than try and put something else out there. We'll see what they recommend, perhaps adopt it, perhaps not, but we don't yet have a recommendation for what to call this concept. To be clear here, in this graph, we have survival probability on the horizontal axis for, say, the current year, 0 to 1, wealth on the vertical axis. Since wealth and survival probability are both good things, an indifference curve will be downward sloping, and under reasonable assumptions, it's also convex. So the VSL, which is what I call it, is just the slope at the relevant point. Because the indifference curve is curved, it's not a constant. It depends where you are and which indifference curve you're on. So VSL is the vertical distance, the change in money, associated with the full run of the horizontal distance there, a change between 0 and 1. It's just a measure of the slope. Alternatively, if you think of a standardized mortality unit, obviously this is not the scale, but the delta R, the increase in survival probability, could be 1 in 10,000. And then the amount of money, the willingness to pay for that risk reduction would be the value per statistical mortality unit. And the ratio of VSMU to SMU is the same as VSL. Okay, so I belabored that pretty hard. Let me also bring up one further point of confusion, I think. When we're looking at the benefits of some intervention in the population, that is defined as the sum over all the affected people of the individual benefits. So if we have some program that reduces mortality risk in a population, the total value of that will be the sum over all the individuals in the population of each person's rate of substitution between their money and their mortality risk and the size of the mortality risk reduction they get. That's the first equation. If it's true, if it's true that individual rate of substitution and individual risk reduction are uncorrelated in the population, you could rewrite that equation as the average rate of substitution, average VSL, times the sum of the risk reductions. And even if these two concepts are not perfectly uncorrelated, that might be an adequate approximation. And then the sum of the risk reductions in the population is the expected number of lives saved in the population, the expected reduction in the number of deaths that will occur in the period we're talking about. So very often you see mortality risk reduction calculated as expected number of lives saved times average VSL. So that is perfectly fine as an approximation, and it's exact if VSL and the risk reduction are uncorrelated. Okay, so now what does VSL depend on? It clearly depends on, as you saw from the indifference curve, survival probability and wealth. It could also depend on a whole range of individual characteristics: age, life expectancy, health, household size, composition, characteristics of the society in which one lives, social support networks, healthcare systems. It could depend on the characteristics of the risk, whether it's a fatal injury or a fatal debilitating disease. It could depend on other things. I think we know something about how it depends on wealth, and so we suggest adjusting for that, wealth or income. We know a little bit about how it depends on age, sort of inconsistently, and I think we don't really know enough about how it depends on these other factors, especially outside the small number of high-income countries like the US with many studies. Okay. So the first thing we did in this project was to do a literature review to look for all the direct estimates we could find in lower and middle income countries. We restricted these to studies of the general adult population, so some sort of a probabilistic representative sample, not a convenience sample. We restricted it to own money for own risk change and to studies where data was collected in the last 20 years, so things are relatively recent and written in English so we could read them. We found 25 studies in total, 8 of them being wage differential studies, revealed preference, 17 of them being stated preference estimates. A big issue with stated preference studies is if you ask, say, different people the money value of different size risk reductions, if you get the same answer from these two groups, the same number of dollars, but you divide by different risk reductions, you get different VSLs. So what do you do with that? And that's evidence that the study is not really eliciting the concept we're looking for. So it's common in the literature to do tests of sensitivity of the value to the risk reduction of the 17 studies, well, 18 separate estimates because one had 2 surveys in it. Half of them tested for whether willingness to pay depended on the risk reduction. So if it doesn't depend at all, that's a real warning. And 5 of the 9 that tested found a statistically significant difference. So the quality of these is not great. Quick overview, 25 studies in 15 countries, a handful in China, Malaysia, Thailand, mostly a single study in most of the other countries. If you plot here on the horizontal axis log of GNI per capita in the country, on the vertical axis log of the ratio of estimated BSL to GNI per capita, you see a big spread. So that's common logs. So on the vertical axis, 1 means a ratio of 10, 2 means a ratio of 100, 3 means a ratio of 1,000. The X's are the wage differential studies, and they suggest this ratio is decreasing with income, which is surprising. I would think it rises with income. All the others, the stated preference studies do show the ratio rising with income, but you see a very wide spread among these ratios. These, the GNI per capita was not adjusted. Those are in different years. So if we did inflation adjustments and so forth, this might line up a little bit more sensibly, but I don't think that would be a big difference. Okay, so now our recommendations are, as I said, if high quality direct estimates for the population concerned exist, use them. But I think a single study is essentially never going to be sufficient because even in the US and Sweden, UK, where we've done a lot of studies over decades, there's a lot of variability between estimates. So I personally would not be persuaded by any single study that they've really got it right. You need a variety of them to have some confidence in that. For many high-income countries, governments have produced guidance on what VSL to use based on review of existing literature, and that might be a good place to turn. So otherwise, which means most of the time, and at minimum as a sensitivity analysis, we recommend this extrapolation, adjusting for income, using GNI per capita as the measure of income because it's broad-based and widely available, not because it's the best measure of resources. And we recommend using PPP adjustment, purchasing power parity, because what we're interested in is the value of risk reduction of the people relative to the value of the other things they could spend their money on. And so PPP is a better measure of the value, the relative cost of different things people can buy. So we suggest 2 base values, and we work here in ratios of VSL to GNI per capita because that, I think, is much more convenient. So our 2 base values are 170 and 80. These are at a base GNI per capita of $54,000 international dollars in the year 2013. And 2 different income elasticities, 1 and 1.4. And then if you use an income elasticity bigger than 1, as you extrapolate to low incomes, the ratio gets smaller and smaller and smaller. And we also suggest the minimum ratio that should be used is 20. So let me now give the rationale for these 2 separate recommendations. First, for the base value, these are based on US government estimates. So we're using the Department of Health and Human Services recommendation, which is approximately the most recent of these. where the central value is $9 million US in 2013. That corresponds to US GNI per capita then was $54,000. That's a ratio of 170. That $9 million is based on a literature review of stated preference studies and wage differential studies that satisfied criteria for validity. So not very many studies in the end. This $9 million happens to be very, very close to values adopted by other US agencies. In particular, Department of Transportation used only wage differential studies, came up with 9.2 million. US EPA actually relies on studies done, in the 70s, 80s or something, and has adjusted for inflation and perhaps income since that time, but they're still right at about the same level, 9.7 million. And then the low value, 4.2 million, or a ratio to GNI per capita of 80, comes from the low estimate from the HHS review. So why US values? Because the US really dominates in terms of having the number of well-done studies over decades, also really stringent, careful review of these studies by these government agencies and academics and the like. Now, it's interesting that US values are pretty high compared with the values for other high-income countries. And that's why we're suggesting using this US central value kind of as a high estimate. We're not recommending something even higher than the US central value, because that doesn't really seem very credible. So that's why we take the US central as a high value and a US low estimate as a low value, 80. And another thing people look to is this OECD meta-analysis of studies done around the world, and using just the studies done in OECD countries, they come up with a ratio of 100. So that is in our range of 170 to 80, at least. We're spanning that. Okay, now the income elasticity. It seems to many of us very plausible that the ratio of value of mortality risk reduction to income cannot fall with income. If you're very poor, you have lots and lots of necessities that consume a very large share of your budget, perhaps more than your available budget even. So you can't really spend much on risk reduction. If you're very, very wealthy, your necessities are covered, and while you can find zillions of other things to spend money on, it seems like you don't enjoy those things unless you survive. So the value of mortality risk reduction seems like it's likely to rise with income. So on that basis, we would suggest the income elasticity is 1 or larger. Think of 1 as kind of a lower bound on how sensitive to income it might be, which means the ratio is the same at all income levels. Then the question is, how large could the income elasticity be? And we do have sort of 2 arguments for what we came up with. One is standard theory suggests that the value of a year is at least the value of what you consume during that year, because life is more than just material goods, material consumption. And then using GNI per capita as some rough measure of annual consumption, and the fact that life expectancy is more than 1 year, even in the worst off places for adults, our value of 20 is sort of 20 future years of average consumption. And that 20 is pretty arbitrary. If you wanted 30 or 25 or something, I wouldn't argue strongly against it. And then our direct estimates that I showed you, I've just argued that values above 170 are not plausible, below 20 are not plausible. So if we drop those estimates and look at the remaining 14 estimates, the interquartile range there is 37 to 98. The median is almost 60. So and those estimates are centered on GNI per capita approaching $10,000 PPP. So then this bottom table says, what happens if you extrapolate to GNI per capita of either 10,000 or 1,000 using our 2 different bases and our 2 different income elasticities? So with income elasticity of 1, you get exactly the same ratio. with income elasticity 1.4, you see going to 10,000, you get a range of 87 to 40, which is sort of close to the 98 to 37. It's kind of in the right ballpark. And then when you go to a much lower GNI per capita of 1,000, you get ratios of 34 and 16. Because that 16 falls below 20, we would say don't use 16, replace that by 20. Okay, last slide. Adjusting for age. There's a lot of intuition that the value of mortality risk reduction depends on age and life expectancy. And some estimates in the US and some other high income countries often suggesting kind of an inverse U, that VSL rises and falls with age. Other estimates suggesting the value of mortality risk reduction when the risk is to a child is maybe twice as high as to an adult. That's a little bit consistent with that inverse U. A thing that has a lot of intuition behind it and a lot of attraction is the idea that VSL is just proportional to life expectancy. And that means a constant value per statistical life year. We're suggesting doing that as sensitivity analysis in a case where the population affected is disproportionately old or disproportionately young, where this will matter. So the way you would calculate this is for the country of concern, you take the VSL estimates I've just talked about, divide that by a measure of life expectancy for the average adult to get the value per life year. So that has the property that you'll value a population of average age adults the same, whether you use VSL or VSLY. But then it has the property that you'll value children quite a lot more than average adults and even more than elderly. That's kind of a sensitivity analysis. And then there's this issue, children, newborns, fetal mortality, where we don't recommend anything specific, but just lots of sensitivity analysis. These can be important. So I'll stop. Thank you.
Oh, it's already set up, so I don't even have to worry about it. The only thing I do worry about is whether I can actually use this. I'm not sure I do. So maybe I'll just, so my name is Alberini. I'm at the University of Maryland, and I'm here to offer some simple comments on the paper and the presentation that we just saw. Okay, so what are the main points of the paper in case you haven't read it yet, or in case you've read it, but it was in a hurry and you've forgotten about it? Point number one, what is the value per statistical life? And here I think that these guys do a very good job describing very, very nicely and very, very well how we really need to interpret this, not something that is the value of sitting a specific person, but a very statistical, very diluted kind of notion. How is it used? Typical in benefit cost analysis, especially the benefit cost analysis of proposed environmental or other safety regulations. How can we form VSL values that can be used in other countries where we don't have original VSL figures for those countries? So here's a simple, I'm not going to put up a lot of equations, so here's a very, very simple one that pretty much summarizes the paper, but also introduces my comments on the paper and also Maureen's comments. So one thing that can be done is what we call a benefit transfer. So we take the value that comes from the US, so you see VSL USA, and we multiply it by some adjustment factor that depends on how the income in the United States compares to the income of the country where we're trying to figure out the VSL for. Now, if you like the equations and this kind of stuff, imagine that alpha is equal to 1. Then you can see right away that if I'm trying to do the VSL for a country where income is half, then in the United States, I simply take the VSL figure and I divide it by. I will let Maureen describe, the concerns that are associated with this kind of operation. I'm going to be talking about something else, and to get to that point, I would like to point out that in the paper and also in the presentation, Lisa and Jim talk about collecting data from VSL studies in different countries and comparing them to the kind of predictions that you get using this particular expression or this particular formula. So before I get to my actual comments, I would like to briefly explain, I'm going to take a very little time to do that, how the VSL is typically estimated, something that maybe you guys could discuss a little more in the paper, go into details. They really give you the difficulty of estimating a value of a statistical life. There's two main approaches: revealed preferences, which you see on the left, and that's what essentially is based on looking at what people do, the stuff that they buy, the jobs that they have, and that kind of stuff. The other one is stated preferences, which means I'm surveying people, and in a completely hypothetical setting with no money transaction, just people say what they would do under hypothetical circumstances. So in the case of revealed preference studies, so based on what people actually do, the typical approach is do a wage risk study that relies on statistical analysis. But if you're no statistician or you hate equations and that kind of stuff, just imagine taking a worker and another worker. They're completely identical for all observable characteristics: experience, training, age, marital status, number of kids, color of hair, anything, but they have different risks at their jobs and different pay rates. And so we compare that to infer what the value risk is. You could do something similar with housing transaction. You could look at how much people are willing to pay to get a car with safety features, advanced safety features, all this kind of stuff. You can look at time versus safety trade-offs. So there's two very nice papers by Leon and Miguel and by Kramer and their co-authors in which they look at how much time people spend taking one route to the airport rather than another, which is less expensive but riskier, or collecting water from a purer source than another. Importantly, you are going to be able to estimate the value of a statistical life if and only if the transactions that you're observing are voluntary. People have a choice and they choose. Otherwise, you're observing somebody else's choice, not the choices of the individual, the choices of the government that have been made for the individual. In stated preference studies, we have two main approaches: contingent valuation, in which they pretty much ask you what is the most you would pay for this particular type of risk reduction. Choice experiments, which I will show you later only after the discussion if I have time, in which you actually get to choose between bundles of goods, risk reductions described by a number of different characteristics. Both of these approaches are incredibly difficult. Statistically, for the number of assumptions you have to make, for the data requirements that you have to make, and I really wanted to emphasize that. All right, so the comments that I will offer now are really based on, are really focusing on the selection of the papers and the studies that go into the $9 million that is assumed to be the appropriate value for the United States, and also the selection of the studies from the low and middle income countries, the 25 studies that all right, so the $9 million that Jim was describing earlier really come from a selection of studies from the US. And these are a combination of wage risk studies as well as preference studies. So they started with a possible set of candidates and they threw out the best candidates right away on the grounds that they don't include women. And that's a problem to me. So anybody that knows the census of fatal occupational injuries, which is the best source of occupational fatal and non-fatal accidents that people can have, everybody knows that women have very low risks compared to men. So in recent years, the risk of men were 5 times those of women. Years and years ago, maybe in the mid-90s, actually the ratio was 8-1. So the fact that these guys, actually the authors of those papers, threw out women simply means that they were really trying to do a good job matching the risks with a specific worker. So they shouldn't have been thrown out. Also, those studies that were thrown out are the only ones that are using longitudinal data and actually instrument for risk, which is really, really important because typically people select into certain occupations and certain risks. Moreover, I always worry that in stated preference studies, we always require the results to be complying with this idea of proportionality. So somebody will pay $100 for a 1 in 1,000 risk reduction. If I offer a 2 in 1,000 risk reduction, they should be paying twice as much, which we typically don't see. But we don't impose this kind of requirement out of wage risk studies for some reason. So I'm going to skip this in the interest of time. In the stated preference studies for the US that were selected as part of the selection that went into the $9 million, by the time they apply all of the stringent requirements, there's only 3 studies. 2 are by Jim Hammitt, and the remaining one is so complicated that I really have a hard time, judging the quality of the study itself. I've known Jim Hammitt, I think, for 20 years. I was trying to remember the first time I've actually run into you, and for 20 years you've been drilling this into my head that we have to have this proportionality of the willingness to pay and the value of the willingness to pay with the size of the risk reduction. But that's really based on infinitesimal changes on calculus. And in the majority of the studies, including one of your own, the majority of the studies, really, we don't have a very small risk reduction. We have a big one. So why should we expect that proportionality to hold? Other suggestions could be perhaps, as you mentioned, to use a little bit more the OECD meta-analysis and the figures used by the health executive. Let's now also, can I have 30 more seconds? Okay, this is just my last slide. So this is the selection of the value-based statistical life from the other countries. So remember, they have a total of, I think, 25. The majority are stated preference type of studies. General consideration, sometimes it's very difficult in a developing country or in a lower income country to do the type of studies that we would do in the US because the markets are not working in the same way. The labor markets are different, the housing transactions are different. In some countries, if you own a house, you'll divide it up to your children, but you really don't put it on the market. So that will prevent us from doing certain things. There's issues of literacy, whether people really understand the type of stuff that they're being asked about. And in the particular selection that you guys did, it would be nice to see a little more information about the specifics of the stated preference studies. The way in which the study was conducted, the data were analyzed, the data were processed, could really have an important influence on the value of the statistical life that you get. The selected wage risk studies do not pass muster with me. They are cross-sectional, they don't have longitudinal data. It's unclear how they attributed the risk level to the particular worker. Often they're based on surveys and they don't even tell you what the participation rate in the survey was. And so I would have a lot of problems with that. Really done. I'm just going to put up this last slide, taken from your paper just as a closing slide, and I'm done. I'm in negative 30 seconds or negative 1 minute. Okay, thank you.
Okay, great. Lisa, Jim, and Lucy have undertaken a very difficult task here, and I think they deserve a lot of credit for what they have done in this paper. Valuing mortality risk reductions in low and middle income countries is very difficult. The first point I'd like to make is that, given the small number of high quality studies and original studies done in countries, being able to use a country specific estimate is going to be, I think, really impossible. Even for India and China, there aren't enough studies. And unless you use benefits transfer, you're going to wind up just not valuing mortality risk reductions. The second point, and Jim also said this, when you're thinking about benefits transfer, you want to look at the ratio of the value of a statistical life to per capita income. When you divide this ratio by 100, it tells you the percent of income that a person would spend on a 1 in 10,000 risk reduction. So using the US ratio of 170, this means the randomly chosen person would spend 1.7% of their income to reduce their risk of dying over the same period by 1 in 10,000. If it's a ratio of 50, they only spend 0.5%. There are some high quality studies among the 25. The high quality studies and common sense suggest, as Jim also said, that this ratio is going to be lower in poorer countries. In countries like Kenya and Pakistan, where people are spending 40% of their income on food, clearly the percent of their income they would be willing to spend, if well informed, for a 1 in 10,000 risk reduction would be lower. So in terms of the benefits transfers procedures suggested, as Jim said, the base here is from the United States. Purchasing power parity income is being used for the transfer, which I think is perfectly reasonable. But once you've done the transfer, you also want to put this in terms of US dollars using market exchange rates, because in many cases, the costs of a project are going to be in US dollars. So you want to actually present the results both ways. And as Jim said, there are 4 cases that they recommend. The $9 million base with a VSL elasticity of 1, so that ratio is 170 to 1 in all countries. the lower base, which gives you the 80-to-1 ratio, and then using the 9 million and the 4.2 million base, but with higher elasticities. And I thought it was useful just to look at what these transfers meant for two countries. So I've done it for Malawi and also for India. So in Malawi, the first column is showing you what you get when you compute the VSL in purchasing power parity terms. You're doing the transfer in those terms, and so therefore the VSL is in PPP dollars, and it's going to range from 190,000 to 19,000. So it's varying by a factor of 10. Obviously, it's going to also vary by a factor of 10 when you translate this back into US dollars at market exchange rates. The ratio of the VSL to income will be the same whether you're using purchasing power parity dollars or market exchange rates. But if you're an analyst and you get these four values, you actually have, estimates that vary by an order of magnitude, which might not be particularly helpful. In India, which has a higher PPP per capita GNI, the range varies by a factor of 5, goes from, in purchasing power parity terms, from $1 million to 200,000. The VSL to Y ratio is not going to get as low because you have higher purchasing power parity income, but you still have a range of values that vary by a factor of 5. The important question, is can you really validate these transfers using studies in low and middle income countries? I really would like to second what Anna said about looking at the 25 studies in the paper and applying additional criteria to them. So for example, when I look at the studies for India, there are 2 of them, there is a wage risk study based on a single cross-section of data that finds a value of statistical life that is over 900 times what the workers in the study are earning. Okay, and this is, I would say that's doesn't pass the laugh test. So you do need to have criteria, just as there are criteria applied to stated preference studies. And when you do have a study that's well done, you want to look at the ratio of the VSL to income for the study population. Because oftentimes in developing countries, if you're asking people about risk, you're going to be dealing with a much more educated group of people with higher incomes, and that needs to be taken into account. What should be done in the short run? I really do feel that using as an upper bound estimate the 170-to-1 ratio from the United States is too high for low-income countries, ones with per capita income less than 1,000 US dollars in 2015 by the World Bank definition, and even for low middle income countries. In a recent Lancet Commission report that Alan Krupnick and I worked on, the Lancet Commission on Pollution and Health, we started with the OECD number as a baseline, and then we chose elasticities. We chose for low, middle, and low income countries, elasticities actually of 1.2. And what came out here in terms of the median ratio of the VSL to income for these 3 groups of countries are what you see on the slide. 50 for low income, 64 for low middle income, and 96 for upper middle income countries. So to conclude, you want to look at this ratio, and one thing that I think needs to be clarified a little in the paper, it's not, if this is the ratio that matters, what elasticity you use to transfer the VSL from one place to another will be determined by your base VSL. So what you really want to emphasize is the ratio. I really do think that using the 170-to-1 ratio is inappropriate for low and low middle income countries. I would look more closely at the OECD numbers, and I would also look at what other countries do. And Jim actually referred to this in his slides. If in Australia, the United Kingdom, and Norway, the VSLs that are being used imply ratios that you see on the slide, it's a little awkward, I think, for the Bill and Melinda Gates Foundation to say that Burkina Faso should be using 170 to 1. So I will stop there.
So we're now moving into our discussion phase, and while you all are thinking about your comments, I'm going to invite our panel to come up, Jim, Maureen, and Anna, to the front here. And Jim, I wanted to see first if you wanted to offer any comments in return, and then we'll open it up for discussion.
Thanks for the good comments. On the wage differential studies that we left out of our review, we discussed that in the paper because they do leave out women. But the more important point might be that I believe we get the same answer, including so it wouldn't change the answer. Maybe we should include methodologically superior studies. So supportive of that. And on the idea that willingness to pay should be nearly proportional to risk reduction, in more recent papers, I worked out in the theory exactly how close to proportional is consistent with our models. And the point is, if willingness to pay is not close to proportional, then what we're saying is the rate of substitution between money and risk depends critically on how big the risk change is, even among very small risk changes. That's not consistent with theory. Maybe it's consistent with people's actual preferences. So if so, then we have to stop using a constant BSL or BSMU. We need to have a schedule that says what the value is as a sensitive function of how big the risk reduction is.
Especially since a lot of the people in the audience are from the public health world, I wanted to maybe say a few words about doing these sorts of reviews. I think the paper's really long. I really appreciate your guys wanting to sort it and getting some sense of what we left out that should have included and maybe some sense of what we can draft. It's incredibly helpful. I appreciate that. We violated, just in case you're wondering, we violated our own requirements for how long these papers are supposed to be. But I've been doing reviews of the willingness to pay literature, I think, since 1990. Is that possible? It was interesting to me to start getting more involved in public health. We have the standards for systematic review, the whole books. And what I realized is that when you're doing these reviews in public health, there are a lot of studies. And you can be very picky and still end up with something useful for the analysis. When we're reviewing the willingness to pay literature, the literature is much thinner, and it requires a lot of judgment to think about how stringent their standards should be. And when is no number better than some number? So I think where we end up is with some inconsistencies between the criteria we apply. As I think Hammitt pointed out, we use different criteria for the U.S. than we did for middle-income countries because we would have ended up with zero studies. And whether that's legitimate or not, I think it's something that is open to debate, but it's a very, very tough thing. What we try to do when we write these up is be very clear, first of all, about what we did, what standards we use, so that if you have different judgments about what studies should be included or excluded, you can apply your own standards and see how it changes the results. We've also tried to be very clear about the uncertainty. One thing that's always been interesting to me about this is that the uncertainty in the BSL estimates is often smaller than the uncertainty in a lot of other parameter values that go into a benefit cost analysis. For example, how effective is an intervention going to be? What is the relationship between some sort of exposure and risk? And often you can have very big, what we think of as big differences in the BSL estimate without changing the results of the analysis. But the point is that we need to be really clear that there is uncertainty in these estimates, particularly when we're extrapolating to low and middle income countries. And as analysts, our responsibility is to think about how that uncertainty affects our analytic conclusions.
Great. All right. Let's see what kind of questions we have. Ask it before you ask the question. recording so that we need, for those who are listening online, but we probably need to use the microphone.
Yeah, people could line up with this microphone. There are people watching online, and this will allow us to record the audio, but also to make sure people are listening online can hear.
My name is Marcus. In general, one of the images that came up when I read your paper was one of the very fast because it was much effective and constant review of the available literature. One issue that I have in thinking about the evaluations of life across countries, comparing countries like Malawi and US, and interpreting wage differentials in terms of evaluation of life, is that was it is lacking one aspect, and that is the utility of money in terms of buying health. In the United States, I think it's plausible to interpret wage differentials and associated risks in terms of evaluation of life. If I look at a country like Malawi, the additional income plausibly would also buy better health. There are much more pressing health needs. They are associated with deprivation with a very low standard of living. So if you compare these empirical data across countries with high income, very low income, you would need to take into account that a low income country, higher income, plausibly buys better health, and that factor would result in lower ESL estimates along the lines that you estimate. But it does not necessarily reflect preferences.
I respond and then maybe ask Maureen, who knows far more about Malawi than I. And I would interpret your point as in these very low-income countries, among the other pressing demands on resources are to invest in health. That's another reason the value of mortality risk reduction would be lower, because if you spend money on mortality risk, that's money you can't spend on reducing other health effects, which are also very pressing.
I agree with what Jim said, and as far as I know, in terms of studies that have been done, wage risk studies, I'm not sure you would necessarily do one in Malawi or in very poor countries for a variety of reasons, actually, that Anna referred to. But I think I agree with what you said, and I think Jim put it very well.
Next question.
Hi, Josh Cohen, Tufts Medical Center. First of all, what you guys are trying to do is, I recognize it's exceedingly difficult, and I'm glad you're doing it, and not me. That's the first thing. And you're obviously much closer. My knowledge is, but I worry about the revealed preference studies. I worry about them all, and you do too. But on the revealed preference studies, one thing in particular that I worry about is that respondents don't have any notion of how big the risk is that they're trading off. I mean, I'm supposed to be a professional in this field. And, I might be buying a car for my daughter, I hope not, but this coming year when she graduates college, and I'll probably get her a car that I think is safe, but I have no idea how much more safe. And so I don't know that. And yet, certainly when we went from Harvard to Tufts Medical Center, I did consider the additional risks associated with that seriously, I mean, I have no idea how many people here have any idea how much safer their car is than another car they were considering. Or I assume that our risks are generally low when it comes to work. But that's what I worry about.
I'm 100% with you. This is one of the assumptions that people do, people make in real preference studies. They assume that people know the risk, and not only that, not only do people know the risks, but the researcher knows the risks exactly himself or herself. So it's a big limitation. And so all of the results need to be taken in every result. There's also another host of considerations that I'm not sure how clear that was over time. I'm trying to segment the so there's this assumption. There is a statistical concern about the fact that people are sort of selecting themselves, so they're choosing a job, and so they're choosing a job that might be riskier because maybe they think they can handle the risk better, and the risk that we estimate from somebody else doesn't apply to them. In wage risk studies, we typically use averages for that particular industry, for that particular profession, for that particular group of people in that age group, for men primarily, because as we know, women have a much lower risk. But that doesn't mean that this particular establishment or plant that somebody's working at is really that risky. It could be a very risky one because it's got a history of blacks controls and everything. These are big assumptions, and so one of the points that I was trying to make in my presentation is that if we believe these figures, we must understand that they come with a big set of assumptions, including the one that you just mentioned. So, good point. I agree.
Yeah, I mean, I think we would argue, Anna and myself and Jim, that studies where you're actually asking people questions where, okay, people have a hard time with probability concepts, which you can test that if you do your survey well, and there should be some sensitivity to the size of the risk change people are confronted with, and so it's possible to do that. And you know, if I were looking at the 25 studies, I do think there are a few of the studies that are stated preference studies that are actually pretty good. But that's my perspective. Maybe Chip wants to add something else.
Yeah, I think that's an important problem. It's actually too bad that Kip Susie couldn't here today, but I think he's going to be teaching them someplace exotic because Kip is the one who's probably done the most work on this. And what's interesting to me is if you read the article that he wrote for about the cost analysis that was sort of a piece of work leading up to this. The conclusion that I come to from that is that in the U.S. we have pretty good data on risk. People still may not understand it, but at least we have good data. As soon as we start moving outside of the U.S., the data on the risks associated with different jobs and also the data that's necessary to tease out the relationship with other job and personal characteristics to wages gets much poorer. So I think there is a real question about, there's plenty of questions about doing these studies in the U.S. They get magnified once you move into countries that have less good data.
Can you just introduce yourself?
Oh, sure. My name is Zidane. So in the formula that you used, we're just taking from income to low income. How do you come to determine the output? And do you have a range of parameters there that you would use again for this material? This is from the literature.
So the formula that was shown is what underlies the estimates I showed you. This alpha was the income elasticity. So we were proposing values of 1 and 1.4 based on the rationale.
But let me also add, though, in terms of the literature, and there is something on page 22 of the paper that needs to be corrected. If you're starting from a low base, if you're starting from the base in the OECD countries, and you use an alpha of 1, the ratio of the DSL to income will be at 100. Okay, if you start with the US base and use an alpha of 1, it's going to be the 170. So the reason I think we would all say your target really should be the ratio of the DSL to income, and then depending on what you use for the base, it will determine what the appropriate alphas are. So I think that needs to be clarified.
Maybe just to highlight, so the alpha in that equation was for extrapolate VSL. If you want to extrapolate the ratio of VSL to income, the exponent is alpha minus 1. It's the same equation, essentially. That's why income elasticity of 1 is the ratio constant.
So in practice, in many studies, they try to estimate the economicity of whatever willingness to pay for a cost reduction, the mortality risk or no paper risk. Internally, so if you're talking about a specific sample in a specific study, often that alpha is actually less than 1. But an alpha 1 historically has been used because it makes sense or because it was a simple expediency by a number of international organizations. And I'll leave the rest to you.
Can you speak into the mic because there are people watching online who can't hear you?
Yeah, the question was, would we report using both? And the idea is, you could think of this as standardized sensitivity analysis. Our proposed recommendation is in evaluating mortality risk. You actually have 4 different values you would use, starting alternatively with the 2 bases and extrapolating using the 2 elasticities. And then Maureen showed examples of that with 4 different values you get for India or for Malawi.
David Differenti. Imagine that over there, another group about this size, the funders with a lot of money and policymakers with a lot of questions. And their question to all of the panel, somebody comes running in with the question, is how much time, how much money would they need to vote to enabling us to come up with better estimates, stronger, narrower ranges of uncertainty. And you can interpret significant expensive.
Well, I can tell you, David, I mean, what I would suggest, I'm not sure how much money it would cost. I think that if you really wanted to try to do, say, the preference studies in low and middle income countries, you would want to take a survey instrument that people have agreed upon as being a really appropriate one. You want to use the same instrument in various countries, although things do need to be adjusted. And I once did a study in Delhi with an Indian co-author, and we had to change the way we asked people paying questions because we realized they were not interpreting them the way people did in the United States. But I would say you want to use just a standardized instrument subject to the modifications you would need to make for cultural differences. How much this would cost, I really don't know.
So I think that actually maybe Sandy can answer this too. Three guys and Sandy have all done studies in low and middle income countries. I think obviously if you have a survey instrument that's already been pre-tested, that's a very different situation than if you're starting from scratch. But my guess is that these studies take 5 years to complete. During that, it's an instrument's already done. But you think it's a year or two if year or two. And if you're not, if all you're paying for is sample or survey administration and then the data analysis, we're talking a couple $100,000, 300, 500 US. Okay.
Next question, please.
Thank you very much. My name is Abu Sarifri. In India. I'm a new person to this group, so apologize if my comments are inappropriate. What I understand in the first presentation, thank you very much for the presentation. We are in the realm of global comparisons of quality of life as well as valuing. My work in demography in India for the last 30-40 years tells me that value of life in a country like India is probably proportional to the number of people who live in space. There is a huge diversity within the I know when you are using GNI, you are trying to discuss those factors, but still, what is that you want to achieve? Highly precise numbers. Maureen's reference to India study, and she was surprised that the rate of return on what you would use was so high. And I believe that results are fairly accurate. I have been working now with the communities in India. I talked to many people, and I try to find out how do they account a living, how do they earn a living, and what is their total investment in their daily life. And I found out we have a few billionaires in India, Reliance, one of the best known, and Tata's very well known. Well, and I was trying to compare what is their rate of return for billions. 200%. But the poor person who invests a very meager amount in monetary terms, I know a lot of labor. The rate of return on often 3,000, 8,000%. That is the power which lays underneath the poor people. They have a lot of, the future GDP in India, if it has to emerge, it will not emerge from the PI investments. It will emerge from a higher rate of return on the very poor people.
Anybody want to respond?
Okay, well, I was going to say, so the study I was referring to, in that study, the average worker was making 8 rupees an hour. And so the estimates that are coming out of that study say that, and so they're maybe 16,000 rupees a year, that they would give up almost 10% of their income for a 1 in 10,000 risk reduction. I mean, that is really small. I mean, it's the idea that they would give up 10% of their income, given that they're making 8 rupees an hour. I mean, and they do have other demands on their income. It just seems very implausible. That was the argument I was making. There are also methodological problems with the study. So in these studies where you're not controlling adequately for other aspects of the job or the worker's skills, then the risk coefficient picks those things up. But I think that the notion that somebody who's making 8 rupees an hour would actually give up 10% of their income for a 1 in 10,000 risk change seems implausible to me.
One more question and then we'll take our break. Well, again, could you introduce yourself, please?
Just now, and also in our comments, Maureen used this kind of legal test. If the value of the statistical life is a certain multiple of median wealth or median income, that it becomes implausible to imagine that actually could be value for statistical life or BSMU in that country. So I was wanting to ask the rest of the panel members, is there really such a thing as a plausibility threshold? I think that even the number $9 million is a large number. It's about, just Googling that number, it looks like it's about the threshold for the top 1% of wealth holders in the United States, if I got that right. So if only 1% of Americans have a wealth of $9 million, does that mean that we should be putting some threshold up there at 1% or 0.1% or 0.01% of American households? Say any value of statistical life above that threshold is implausible. So I wondered if you could talk about these plausibility tests in terms of not just willingness to pay, but basically ability to pay.
Let me address the example of the $9 billion that Maureen talked about other issues. We don't expect anybody to spend $9 million to reach the rest. There's a table in the paper that maybe we should have reproduced here. This is the problem with the VSL concept. It's everybody, if you envision somebody reaching into their pocket and pulling out this full amount, it's $9 million or something else. But all we've done is we've taken an individual's willingness to pay, which for the average in the U.S. is $900 for 1 in 10,000 change in mortality risk. We divided it by the risk change, I guess it's $9 million. So the studies are suggesting to us that in the U.S., the average person would spend $900 to use the risk by 1 in 10,000. So the $900 is the money to focus on. Where if it's 1 in 1 million, risk change, that's $9.
So is there a possibility threshold to that 900?
That's a good one.
Well, I mean, the argument I was making really was going, well, first of all, it's based on two things. One is when you do look at studies in countries, in OECD countries, you look at studies that the 100 to 1 ratio is based on. I don't think you can really throw all of those studies out, and they're saying something about, assuming they're accurate, again, about what people would pay for this small risk change in countries that are actually much, that have much higher per capita incomes than the low and middle income countries like they do. And this is what those data are telling us. The plausibility argument I made on the first slide was that if you look at a country where people are paying like 40% of their income for food, the notion that they would be paying, I mean, 1 in 10,000 risk change is very small. So if they have to buy 2 of them, that would be almost 4% of their income. So that's sort of the plausibility argument I was making there. In terms of the studies in the U.S. and whether those estimates are plausible, I'll leave that to the other panelists to comment on. Yes.
We want to use spending on food as a comparator and establish a threshold for all about food people, especially in India, who are nourished. Reducing their food consumption from 40% of like 18% or 10% would actually have mortality effects in the population. So is there some plausibility threshold that could be established that way?
I feel like you've sort of hit the nail on the head in terms of what's so difficult about this type of work. As I said in the introductory slides, what we care about are people's preferences. And what I have learned is that I, as an analyst, particularly a well-educated analyst who spends a lot of time thinking about themselves, about this stuff, too many thoughts at one time. It is really dangerous for me to be thinking about how somebody who's very different from me might make these trade-offs. So I feel like all we can do is do a lot of these studies. I don't want to take up time now because it's time for the break, but I can tell you lots of stories of having sat in focus groups in the U.S. And being really astounded to realize how much different people's preferences are than what I would assume they are. So I'm worried about doing that because I think it moves about coming up with some arbitrary threshold that's not based on research about people's preferences because it implies a judgment by us that may not actually apply to them.
I was going to say that sounds like a great stopping point, and we will resume at 10:15. And let's thank our panel.